Now, this is what you should go. This is the transfer function. This is actually equal to the transfer function. So I'm going just to show you what's happening inside there on the first order equation that you see. So this is what we have: the output over the input, okay, which is equal to 1 is plus 1, okay. And it said here we got the unit step as the input. So the input is rs. This is the input. Ys output, and then gs transfer function. Okay, so we have something like this. Now we know that our input, it's actually equal to a unit step. So I'm going just to use this one. We're going to have a unit step, okay, and the unit step equal to 1 over s. So meaning we and this question we need to solve for for the output. So we need to find the output in times domain. So we need to solve for the output in times domain. So first let's solve for the output, and we know this is what we have, okay. This is what we have. I'm going to zoom in, and then if I have to solve for the output, I'll get something like this. So we're going to multiply or multiply both sides by rs. So this one's going to cancel out. You can actually move it there, so it's gonna be transfer function times rs, okay, meaning this is the transfer function, okay. And the equation of the transfer function is this one times the input, and we have a unit step, so it's gonna be 1 over s, okay. So this is what you see right there, okay. So now what we're solving, let me correct it, it's actually y, we have ys here, so we need to create to yt. So in order to move from s domain to time domain, we use the inverse Laplace. Use the inverse Laplace, okay. So we use the inverse Laplace. So if we have to get the inverse Laplace, okay, and then we need to take another inverse Laplace on both sides of the equation. You can clearly see that there's this form. We can't find it into the table, so we can see that this form, is missing into is missing into the Laplace table. If you check the one on internet, okay, you will see that this form is actually missing. Okay, so since we don't have this form into the, so I've imported the Laplace table so then you can see. Okay, if you check for the form that we got here, this form, if you check here on the Laplace table S domain, okay, so this side is times and this side is S domain. Okay, you can see that in all the tables that we have here, we don't have this form, so this form is actually missing. So since this form is missing, that's why we take, or if I can we look for the partial fraction. Okay, and we're going to solve for the partial fraction of this equation. So we know this is what we originally had. Okay, so it's gonna be 1 ts plus 1 times 1 over s. So what is the partial fraction that we're going to get out of this equation? There is a partial fraction table that we use. Okay, so this is the partial table that we're going to use to get the equation out of this fraction. Okay, so now we need to identify which form we have. Okay, so as you can see, we have 1 over s. Okay, so this is similar to writing the whole equation in this form. So it's gonna be s plus 1 times s. It's just the same, but if you have to write it in terms of partial fraction, okay, so we need to write this to find the partial fraction of this equation here. Okay, so it's gonna give us, we need to check into the table. Like I said, we have s times something. This is where you see s times something, and then you see what happened to s. So it's actually the same as writing a over s plus, we're going to have another fraction here. Okay, so let's look for something similar to what we have here. Okay, so what we have is something similar to this block here, and you see just a repetition of what you see there. So you can actually see even here, just to make sure, and even here you see what's happening. So we're going to write it as b ts plus 1. Okay, so I'm going to zoom in. This is what we're gonna get. Now the way to move forward from here is we're going to multiply both sides. You're going to multiply both sides by the denominator that you see there. Okay, so meaning we're going to have to cancel out the denominator. Okay, so it's gonna be s, we just use something that is more visible. So it's gonna be s ts plus 1. Okay, so this is what you're gonna see, and we're going to multiply it even this side. It's gonna be s. So let me just save sometimes by copying what I need to multiply with. So we're going to multiply both sides by this. So you multiply all the numerator. Okay, it's gonna be something like this that we're going to get here. Okay, so there's nothing changed. We just took the denominator here and then multiply it with all the numerator. So let's say all the fraction that we have, multiply it with all the fraction that you have. So we end up with this form, and you can see that this one is will cancel out with everything there. S will cancel out with that. Okay, and this block will cancel out with this one because you can see it with what is inside. So we're going to write it like this: a s plus 1 plus b s. So this is the form that we're gonna get from where we started. Okay, so now here the goal is we're going to solve for a and b. Okay, that's what we're gonna do here, and we need to have some condition, some rules. Okay, and if you don't want to make a condition, like for example, if a equal to this, or there's this condition that we actually like having, let's say if s equal to 1, or maybe s equal to 0, what we're going to get. Let's start with just this condition here. So I'm going just to use that color. S equal to 1. Okay, we're going to have we get 1 equal to a t plus 1 plus b. So, and what we're going to have here, it's gonna be 1 1, and then which is gonna give us a t plus 1 plus 1 plus b. Okay, and if I go if I have to write what we just got here, so we got 1 equal to a t plus 1 plus b. Okay, we can easily solve for b. What is the value? What is the answer for b? B will be equal to 1 negative a t plus 1. Okay, so we need to solve for a, and there's also this one that I always try when I start with solving for partial fraction. Let's say s equal to 0. Okay, we get this. So it's gonna be 1. I can even just copy this block. So this is what we have. and instead of 1 we're going to have a 0. Okay, if we have 0, you can actually see that this one is going to cancel out. Okay, and we'll be able, and this one is going to cancel out, so we're going to have a times 1, so it's gonna be 0 plus 1. Okay, so we know 1 equal to a times 1, which is the answer for a, so meaning a equal to 1. That's what you see here. Since a equal to 1, we're going to replace into b, so then we can solve for b. Okay, so if a equal to 1, what's gonna be b? So we know b equal 1 minus a plus 1. Okay, and if you have to solve for b, what is the equation for it's going to be, so let me just it's gonna be 1 negative a equal to 1 times t plus 1, and this is what you're gonna get here. It's gonna give you 1 negative t negative 1. Okay, so this is what we're going to get here. So negative, it's 1 is going to times everything inside with and the sign is going to change, so you can even see that these two will cancel it out because they are both 1. So we're going to have a negative t for b, so b equal to negative t. That's what we get for b. Okay, and initially we have we had this equation before, so I'm going to replace the unknown with the exact value. Okay, so this is what we had before, and as we have seen, what will be the what is the value of a? We're going to replace it by 1. And what is the value of b? B, it's negative t. Okay, and just because we have a positive sign, it's gonna be going to move the negative sign there, so it's going to replace that positive there. So in short, we're going to have a negative sign here. So this is the answer for the partial fraction, and with this you can get this form into from the Laplace table, and then we should be able to solve this question. Okay, so this is what we did to get to the partial fraction. Okay, to break down and get our blocks, and then if you have for verification if this is correct, you can just solve for, if you solve for this equation, you just minus them the way they are. You should get back to this equation to prove that this partial fraction we got, it's actually equal to what we see this side. Okay, so let me just start over. Now we're going to look for the common denominator, which will be something like this. So we're going to times both denominator, this one and this one, times. That's what we're gonna get as our common denominator. Okay, once you get your common denominator, we're going to have minus, since we already have minus, so it's gonna be this common denominator times the numerator there and divided by it denominator. So we're going to take the common denominator, it's gonna be what you find. It's gonna be 1 times the common denominator over the fraction that we have for the first one, and the same goes for this side. So it's gonna be the t that we find there times the common denominator over its own denominator. So we're just gonna multiply the common denominator to both fraction. So just if I have to write it in a correct way, so we're actually going to have this scenario. So it's gonna be s ts plus 1, okay, negative sign there, 1 over s, okay, times, and then we're going to have t, it's gonna be times s something like this, plus 1, and even this side ts plus 1. Okay, so what you see here, then we'll be able to, you can see that s and s will cancel out. Okay, and since I forgot to add the denominator to this block, so remember there's a denominator here, so we're going to have ts plus 1. So and then you're going to see that this one and that one inside here, they will cancel out. So we're going to end up with this fraction s ts plus 1. Okay, so it's gonna be 1 negative okay ts. This is what we're gonna get here. So and don't forget that there is a plus ts inside there. Okay, on the first so this one is gonna give us what you see here, and this one is gonna give us what is going to remain here. Okay, and if you look closer, this one and this one will cancel out each other, so we're going to remain with 1 s ts plus 1. And as proof, this is what you get on your what we had before on our partial fraction. So I'm just to give you an idea of how you can get to the common denominator. Okay, so if you don't know how we do common denominator, this is the way around these things that you should know. So I'm going just to clean up and just write what we have obtained. Okay, so in short, this is what we just did. Okay, in a long way. Okay, if I can also just adjust things, this is what we got. So okay, so this is what we got, and these two will cancel out each other, so we're going to remain with 1. Okay, so this is the proof to prove that we got our partial fraction and it's actually correct. Okay, just to make sure. Now we're going to go back to our question and see. So now we have obtained our partial fraction. This is the partial fraction that we have obtained. Now if you go, we need to take the inverse Laplace. Okay, so now it's possible for us to have the inverse Laplace. So we were tasked to find the inverse Laplace of ys that you see there. So in order to obtain the inverse Laplace, we're gonna take the partial fraction since it's just the same. Okay, so and we should be able to get yt. Okay, and if you check into the table for the form that we have here, 1 over s, it's actually the first one. Okay, 1 over s plus 1, where is it? 1 over s plus 1, it's actually this one, but the sign is going to change. So meaning if a it's negative here, that's why this side we have positive. So if a this side is positive, this side we're going to have negative. Okay, so we're going to use those formula. Let's start with the first one. So 1 over s in times domain, it's gonna be a unit step. So, or maybe writing as 1. Okay, we actually don't, we prefer writing it as a unit step. Okay, it's the same as in 1. We have a negative sign there. Okay, don't forget about the sign that you see here. Now we're going to write it in this form. So it's gonna be e to the power of a times t. So what is a? So we need to find what is a here. Okay, and then there's this thing that we need to write this equation into this form. Okay, so how are we going to write our equation into this form that you see here? Okay, and our equation, we have something like this: 1 over plus 1. So I'm gonna write this one into the form that you see there. Remember, this t we're not considering, we're going to focus on s. So I'm going to divide both sides by t, and even here, so I'm going to divide both sides by t, so for me to get around with this. Okay, then because I'm going to divide both sides by t, so it's going to be 1 over s plus 1 over t. Okay, that's what you see there. Then I will take the Laplace of this form. So it's gonna be actually similar to what we have there. So instead of me writing this one, I'm going to use this one that I got here. So it's gonna be 1 over t. Okay, 1 over t. And since we have positive inside, we say that if we have positive, you see a it's positive, that's a this side is gonna be negative. Okay, so that's why you see we have a negative sign there in the numerator. So this is what we get, or either we can write it in this form: 1 negative e negative 1 over tau over t. So we're going to have this is the answer that we're going to get for this question. And that's what you see here. Okay, and in summary, this is what we had before. So you look for the transfer function, you replace your unit step, and then you get this form, and then you apply the partial fraction because of this form is not into the Laplace table. Then once you get that, then you can take the inverse Laplace. So we just explain everything starting from the start to the end. Okay, so this is what where we started and where we finished, and this is where we did the partial fraction. Okay, so and this is what we did to prove for the partial fraction that it's correct. Okay, this is it. All right then.